This episode of Liquid Assets is sponsored by HASA, the leader in water treatment solutions. HASA delivers eco-friendly, reliable, and cost-effective water care and has been keeping communities safe, one drop at a time. They've been at it for more than 60 years, and you can learn more about HASA by visiting hasa.com. That's HASA, HASA.com. Welcome to Liquid Assets. Liquid Assets is a podcast about water through the lens of policy, business, and technology. I'm your host, Robbie Karani. Today we have an awesome guest for you, Cydian Kauffman. Cydian, how are you doing? You're calling from Seattle, right?
Hi, my name's Cydian. I'm the owner of Pure Water Northwest, and in this podcast, we're going to talk about the future of water, the present of water, and what's in your water, which might scare you, but we got solutions, so don't worry about it.
Yeah, let's just jump into it. We were chatting right before I hit record. What I want to jump into is the future. 100 years from now, you were saying there's a lot of cool stuff that's on the horizon, a lot of cool stuff that's happening now. What does 100 years look like within the lens of water? And you mentioned water and power. So what does that mean?
So water and power are currently linked. You don't have to have fresh water to have power, but you have to have power to have fresh water. And you do have to have water to have power. You have no power at all, except for coal. It is possible to get some power from coal without water, but obviously hydropower we already know. But the main source of a lot of our power, which is still nuclear facilities, all require water, and they actually require pretty clean water. The fact that power and water are so linked, it's a really interesting thing, because if our grid goes down, so many people are going to be without clean water. If somehow our source of water gets shut off, which is very hard to have happen, but if somehow that happened, we'd run out of power. So the future, though, on this is so neat. The fact that in the future it's going to be just as linked. We've just recently, in a perfect lab environment, created cold fusion. That's happened in the real world, but it's perfect settings. It's not replicatable easily. People are still vetting whether or not it went down the right way, whether it actually produced it in the way you would expect. But what that leads to is using seawater, which is a source. It's an incredible source of power. Deuterium, it's a heavy isotope of hydrogen, right? It makes up roughly, I don't know, a little under 1% of hydrogen in seawater. But that means a whole cubic meter of seawater contains enough deuterium to yield energy equivalent of 300 barrels of oil if you could access it, which cold fusion would have the ability to do. So in a really neat future, this is probably 100 or so years away, but in a really neat future, our seawater simultaneously powers the city that it's next to, as well as a huge swath of inland, and provides water, clean water, as a byproduct of that action.
That is awesome. I want to unpack a few things you said for the audience, just to kind of level the playing field here. So kind of starting off with the beginning of what you said, can you kind of just restate that you need water to make power outside of obviously coal, which you can just burn, right? But just hydropower, nuclear, we need water to make power.
Exactly.
And the reverse, what did you say about the reverse? That
you need power to have clean water.
To have clean water, because we need to pump it across the actual distribution that we have.
If power went down, the water in your home will at some point stop. You'll turn on the faucet, there won't be anything there. Some people have it for a while, but it won't be there, right?
Yeah.
It won't be clean. We have some ways to clean water for a while without power, but then the action to clean the things that's cleaning the water will stop. So at a very short time span after we lose power, we lose water. And then where are people getting water from when they've spent their whole life just turning on a faucet to get water, right?
Totally. I actually want to put a bookmark in that for the audience. I'm going to come back to that in a second. You then moved over to nuclear, and you talked about we got close to fusion, which basically, maybe you can explain the difference to the audience for fusion versus fission, because you might go along the California coast. You've seen a nuclear reactor on TV, and that is primarily fission, what we see. just explain the difference and kind of what is fusion and fission. And then you mentioned tritium and
Deuterium. I am not the person to explain the difference between fusion and fission, honestly. But the people who did this, like, they're amazing. People, I'm sure anyone who's listening is right now just Googling it, so they'll figure it out. But the people who did this in this like perfect like lab environment, I think they did it in a vacuum even. They were able to actually produce a tremendous amount of power from just this tiny little merging of atomic particles, essentially, to create a byproduct. I mean, that's basically just the action that occurred. Like, I don't fully understand that because I'm a water scientist, but the action that occurred leads to a future that is just going to be nuts as far as power goes. I mean, cold fusion means we are in an environment where it doesn't require thermal deregulation. Like, you don't have to like massively cool things. You can create similar power to fission plants. Like, not quite the same, but you can create similar power to that. But heat is the main problem with nuclear reactors, right? That they produce so much heat, and you have to constantly cool them, and you have to cool them with clean water, because if you're pouring dirty water over these things, you're constantly having to shut the entire thing down so you can clean the rods inside the factory or the reactor. So basically, if you have the ability to produce that without having to constantly cool, that is a tremendous access to energy.
And you then mentioned this point about I keep on butchering this, but it's
Deuterium, yeah.
Deuterium. I keep wanting to.
I think I'm saying it right. Honestly, I've only ever read it myself, but yeah,
and
deuterium.
That was 1%, under 1% of all seawater. Can you just re-explain what that? Because I think that's like absolutely amazing.
Yeah, it's like 0.015% or something like that, or 0.15. I can't remember, but it's close to that. And so it's like less than 1%. But if you take a cubic foot of seawater, that's going to still have enough in it, enough energy in it, that it would be equal to about 300 barrels of oil in 1 cubic foot of seawater. Meaning there's enough power out there in the ocean to launch rockets into space and power sky bridges and like power space elevators and all that kind of stuff. I mean, our future is, most of our present is limited by access to power, access to easy power. So our future is very, very much going to change on every metric as soon as that occurs.
That is amazing. I'm so happy that we opened up with this topic. I think that leaves a very positive view of the future. If we come to today, you had mentioned just a second ago that power is the limiting factor to unlocking much of this, all of this.
Right.
What are the slew of issues that we should be, outside of cold fusion? What else should we be kind of looking at, both from like the water and or power side of things, that you see that people either are working on today that are cool innovations that are going to project us into the future, and maybe even kind of spots that we're not focusing on?
There's some neat innovations into algae, using algae as a way to clean water without needing power. And the output, I think they're genetically modified algae, and the output for them is drinkable water, green drinkable water, but drinkable water, because the algae is grabbing the metals and VOCs that are in the water and basically removing them from solution. That's kind of neat. I mean, I honestly don't know a ton about that, but when I read it recently, I was like, wow, that's a cool innovation. The action that we have with reverse osmosis, as like, that's an old technology, but it used to be very inaccessible to people. I mean, RO was like this thing that cost thousands of dollars, and then the upkeep on it was just crazy. Nowadays, reverse osmosis membranes are cheap, which is cool because they're not an easy thing to create. But obviously, the process has been gotten down to a point where people can develop them. And the reason why this matters is because RO is going to remove a massive majority of contaminants in water. So people who have no easy way to get access to clean water or can't figure out what's in their water or can't afford it, they can get a cheap RO. I mean, it's funny. The Flint, Michigan thing was handled how it was handled, right? 30,000 homes without access to clean water. 30,000 people with children, 30,000 homes with children drinking water, which is like over 100,000 people drinking lead, actually having their future completely altered by the fact that they're drinking so much lead in their water. Dramatically changing the society in that area, just because the infrastructure had been putting lead into the water for ages. I don't know, it took like 10 years to resolve that or something. I don't know why they didn't just like make a deal with a Chinese manufacturing company, have them send 30,000 reverse osmosis units for what that they probably could have got it for $500,000 or something. Have people who could install it themselves install it, and for the rest, they give them a coupon. They call up their own plumber. They hand the coupon to the plumber. The plumber installs it, and the plumber exchanges the coupon for pay from the government. Probably would have been $1 million, something like that, and everyone would have had near instant access to clean water again. RO technology is amazing. It solves a lot. I have no idea why that wasn't done there. It would have given people access to the water so they had time to fix the infrastructure. I don't know why that didn't happen. That's strange to me. RO technology solves a lot of problems for people. So the fact that it's now less expensive and accessible is great. You still want to check your arsenic, and I think it's barium or cadmium. One other thing, RO technology is not great at that unless it's in an altered form. But yeah, RO is fantastic.
This is actually a question that we get a lot, and I think you touched on a few points here. Even going back to that really cool algae technology as well as RO is around the cleanliness of water, right? There's all this stuff around microplastics, PFAS. You just mentioned, arsenic. I guess two questions there. One is, should everybody just get an RO system? Like, should we just all go to Amazon right now and like order the kind of cheapest RO system or do you have any recommendations on that? And then, like you mentioned, once we do have that, what else should we be looking out for? And does it filter out everything that it should be filtering out?
That's a good question. So I'm going to preface that question, I'm going to talk about arsenic. Anything that's on the periodic table of elements could be in your water, theoretically. If you're on city water, all that's going to be dropped down to below a certain level because the EPA sets a legal limit for what can be in your drinking water. Now, the legal limit is not the same as the health limit. They set two standards for drinking water. The health limit is set as close to the legal limit as is feasible given cost and other considerations. So you're allowed to have arsenic in your water, and I pretty much guarantee that some of the listeners do. The Department of Ecology shows an arsenic map, and anyone who pulls up these maps for their area, it is very likely their entire state is covered in orange and red, because arsenic is just massively prevalent in many places. Because of that, and because of the hydrologic cycle, which is, water dropping on mountains and traveling across the land until it is dropped into a reservoir or aquifer where it is then captured for drinking. When that happens, you're going to get some arsenic. You're going to get some everything in your water, PFAS, microplastics. There are definitely microplastics in nearly every water or river source. Recently, they did a test on like 19 rivers in the middle America, and 17 of them, maybe it was 23 sources, and 19 had PFAS, forever chemicals. I mean, it's definitely in many, many sources. There's 100,000 theoretical kinds of forever chems. There's about 30,000 roughly identified, only 6 strongly identified, because the technology to go down to that scale is really not the best right now. So we have only identified 6 strongly, like, yes, we know these, we know what they tend to do to people, that kind of thing. And so those are the only 6 we're testing for. So we've got a lot of stuff in water, for sure, that's at some level. Whether it's dangerous for you is very dependent on your body. Your body is a homeostasis engine. It does its job to keep you in balance. So it's going to be doing its best to make it so that whatever you take in is filtered out. But if you don't have a filter, your body's the filter, if that makes sense. So an RO is fantastic. It removes almost everything. Ironically, unless it's in its oxidized form, it only removes about 50% of arsenic. So if you're on a well and you get an RO, you may still be drinking some arsenic there, and you may want to do something specifically about that. And testing for it's a good idea. In most city water applications, though, they do chlorination. Chlorination is one of the best ways to oxidize. So the arsenic that you're drinking in your home is likely the oxidized form, and an RO will be great at it usually. So, I mean, 90% of homes that are on city water will be able to get an RO, put it in, and have a very strong faith in that water. Sometimes people talk about RO technology as taking out too many minerals. You don't get your minerals from water. Like, you get some, but that's not the main source of where you get minerals. You get it from food and vitamins if you take them, but mainly food is where you're getting minerals. The amount of water, the minerals that's in the water you drink throughout a day is less than you might get in a single slice of bread or a salad. One salad, half a salad, depending on how mineral rich your water happens to be, the highest it can possibly get does not exceed a half a salad. So it's not your source for minerals, really. It's a good way to get your body clean and to hydrate so that the cellular action of your mitochondria are functioning better, and that's what we need water for. So getting clean water is fantastic.
And will an RO system also remove the 6 types of PFAS that we've so far dialogued, as well as the microplastics?
Yeah, almost every RO is going to have carbon ahead of it. Now, if you get a super cheap RO, it might have a cheaper form of carbon that's not catalyzed. And all that means is essentially they acid wash it to release the pores inside of the carbon so that it has more filtering power. If you have a good catalytic carbon, even a regular carbon, you will get some PFAS, and then the membrane will do the rest. RO technology is definitely a reliable way to get rid of microplastics, to get rid of forever chemicals, to get rid of chlorine byproducts, oxidized arsenic, although it'll even remove a little bit of the other. It's going to have between a 85-90% to even 99.9% removal of almost everything in your water. Some things are down to 40%, but those things are not quite as bad for you. You'd have to have them in massive numbers. It's not to say that for 100% of people an RO will be like perfect, but for 90% or more of people it will be. And for those others, we do always recommend testing just to make sure. But generally, if you're not going to test, it's a very safe bet.
So I want to kind of summarize that for the audience. RO here obviously is the thing to get for your house and your sink, and
reverse osmosis. Yep.
Reverse osmosis. And do you have any systems that you would recommend, or when you said kind of a cheaper versus good? Is there like a metric that I'm looking for? Is it NSF certified? Like, what does that look like?
Yeah, you want to get something that's NSF certified, but honestly, since I sell an RO at my company, Pure Water Northwest, I probably don't want to just recommend random ROs, but I partially don't want to recommend random ROs because the failure rate on ROs for leaking is a little bit higher than people would expect. ROs work under high pressure. That's part of how they do their work. So a surprising number of them leak, and I'd be a little bit afraid to recommend something and have it leak. Looking at reviews is a way to do that. We sell a very simple commercial grade RO with a tank. If you get a tankless RO, the technology is not currently to a point where the first run of water out of your dedicated faucet is going to be the cleanest. You have to run it for a second before then putting your faucet under it. And for some of them, you have to run it for a full minute. So no one's going to do that. So they're drinking water that is improved, but not to RO level very often. If you have one with a tank, that is a dilution. So the water pours into it, and then good water continues to fill it, and then that's how you get to that 90% to 99%, because the way the technology is currently for point of use ROs, we're not having opportunity to fully get that first run out of it perfectly clean. Does that make sense?
Yeah, definitely. And so this almost poses a problem for your person that might live in, New York City or something like that, or in Los Angeles, that just has an apartment that wants to get, you see these little things you put on your tap, and they're just little carbon filters. What's the solution for somebody that like lives in an apartment that obviously wants clean water? And yeah.
There's so many reverse osmosis systems that you basically sit on your counter, you plug in, you pour stuff in the back, and it does the work for you. Those ROs are great. Pick one with a clean water reservoir is my recommendation, because then you're not running into that problem I just mentioned. Those are fantastic solutions for people who live in small apartments. Sometimes there's also a hole that's already there in those apartments, and you can then do an under counter system. To install an RO, you're drilling a hole in a counter if there's not one there, putting a dedicated faucet, then you're interfacing with the cold water line, running the water through the RO and out that faucet. That's basically how you do it. So if they just integrate that in a box and you just pour the water in the back, same thing.
I want to go back to something you said about the EPA. You said there's a legal limit, and then there's a healthy limit, and that legal limit comes as close to the healthy limit as possible. What was that? Just because it's hard to achieve the actual healthy limit? Like, what's the story there?
Yeah, I don't want to bad talk the EPA right now, because if you think about it, if you've ever visited like a water treatment plant, they're taking up a geographical area the size of a football field already to clean your water, right? So if you can imagine, if they're getting something down to 0.001, for example, so they get the arsenic down to 1/10 the legal level, meaning 0.001, but still above the health level, which is 0 for arsenic. You shouldn't have any arsenic. But if they're getting it down to 1/10, using something the size of a football field to do that, they actually, the way it is, it's not logarithmic currently. They would actually potentially have to have something that's the size of 10 football fields to get it down to 0.0001. So it's just not realistic, right? They've been able to improve stuff by having improved technology over the years. I mean, carbon has been used as the main source of treatment for ages because it's truly amazing. If you take a single gram of carbon, like this much carbon, and you were to take the surface area that's in all the little tunnels inside of it and spread the surface area out, it would cover 3 tennis courts. Yeah. So that's why carbon is so good. If things travel in it, they travel through those tunnels, and then by adsorption, because carbon has a very weak pull, by adsorption, it sticks to the side of the carbon and doesn't continue traveling through. It's attracting every single contaminant there is. It's just not perfectly attracting every single contaminant there is. So a lot of people think, I'm just going to put carbon in and it'll do the trick. No, you test after carbon, you're still getting arsenic, you're still getting lead, you're still getting tons of stuff, but it's lowering a lot of that. You put chlorine and chlorine byproducts through carbon, you pretty much have a down to 0 reduction. So carbon's good at some things, not good at other things, but it's amazing still. I mean, it's one of the few things that seems to target everything loosely, if that makes sense.
Yeah, definitely. I want to take a turn and kind of go into the life of Cydian. You have a company, Pure Water Northwest, and I would just love to, like, how did you get into this? How do you know so much about water? What made you start the company? What's your story?
Well, I just want to start by saying I don't know a ton about water. I know that may surprise people, but there are geniuses out there who know 10 times what I know. I seem to have a decent ability to communicate it in a way people can understand it, which is why I get on here and do it. I've been doing water for 7 years. I've been studying it for that time because I am one of the owners in a company, Pure Water Northwest, and I'm just avid and obsessive about getting water right. So that obsession has kind of led to me learning what I need to learn in order to be able to get water right. That's how I just know all these random facts, because I've had to learn them in order to make water good for people. We have dealt with some of the most troubling and difficult problems in the state of Washington. There was one time where my mentor, Chris Pelton, came upon a guy who had 50 of his cattle die. And he just bought the property. He took a trip. He moved his cattle on. He came back. And luckily, and I say this because it is lucky, surprisingly, luckily he walked out before he drank his water, and 50 of his cattle were dead. And they had a naturally occurring cyanide spring, which is not cyanide's not something you can just have sitting in an aquifer. So it was something that very rarely was created by the vegetation in the area, seeped into the spring, and then as the spring was bubbling out of the ground, was just creating cyanide in high enough dose that it killed cattle, meaning it would have killed him. Like, he wouldn't have tasted it at all. His stomach would have just started bleeding or something. So we fixed that. Water systems engineers said it would be easier to get water from the moon than to fix this water. And Chris, who's smarter than me, he was like, nope, we just need to do this, this, and this. And they were like, okay, that would work. Water's like a puzzle, you know? It sometimes it's easy, but sometimes it can be incredibly complicated. And it can be like a Tetris game in that you have to fit something here before this other thing will work. It's just really kind of fun once you actually view it that way and see it that way.
What did you do before the 7 years that you got into this? And I guess, what was the inflection moment that you're like, hey, I want to be an investor, I want to buy this business, I want to work here? What was that turning point?
I was actually a property manager. I managed like 400 doors at one point, and wow. I had a lot of clients on well water. One time the tenant asked me to look at their water, and they had like a rotten egg smell, and it was brown. And I took it to the lab, and when the lab came back with their report, they handed me a piece of paper, said this water's healthy. And I was like, what? There's no way this water's healthy. And they were like, oh, they corrected themselves. They said it's within the legal limits. And that's because labs, for some reason, even though they know better, they just constantly conflate healthy with legal with healthy, healthy with legal with healthy. They just conflate it for whatever reason. And they should stop doing that, because they are technically speaking incorrectly per the EPA. But after figuring this out, that's actually when I reached out to Chris at Pure Water Northwest, and I asked him about it, because I was reaching out to water treatment people to see what we could do about it. And he's the one who explained to me the difference. And my daughter had a skin condition, and I mentioned it to him, and he thought that I should get a softener after I described what she had. And the softener worked. She doesn't have eczema anymore at all. I've spoken to dermatologists about that, and they say it's very person specific. And I'm like, cool. It fixed my daughter's eczema. We don't have that. She hasn't had that for the last 5 years. That was why, I was like fascinated by the idea that so many things are still allowed to be in water, and that so many people are just drinking it, and they're fine. They're alive, right? But they're getting inflammation from it. We don't know if that's what's causing organ failure or heart failure at some point in their life. We don't know if that's what's causing cancer for some people, because water is so slow at doing what it does. It's like it's this realm of like, it's safe to drink. Is it safe to drink? Is it not safe to drink? It's kind of better to just make sure we know it is safe, and then just drink that water. That way we can have certainty. Yeah.
This has been super, super insightful, Cydian. I asked everybody one last question before we say goodbye, and that's, is there a book, a movie, or a TV show that has had a profound impact on the way that you see the world?
It's kind of silly, but like The Matrix changed my viewpoint about the world. I've had many movies definitely affect me. I've had many movies affect me in a lot of ways. Eternal Sunshine of a Spotless Mind definitely affected me. But The Matrix definitely was, and I know it's been co-opted in many ways because it had the same effect on so many people. But being able to actually look at the world in terms of paradigms and viewpoints and perspectives has helped. I mean, it helps you talk to people. It helps you know that when you're saying something, you need to think about what they're hearing so that you can modulate what you say so that what they hear makes sense to them and not just to you. I mean, it got me into my study of the Pygmalion effect, actually. Although that was mainly Invisibilia. Invisibilia is a podcast that's like, to me, top tier, or it was back in the day. Maybe one of the best podcasts ever produced. And I want to change my answer to that. Their podcast about, I think it was called Bat Boy, about this kid who was blind and the parents didn't treat them like they were blind. But at the school they went to, they definitely had this like, you're blind, you can't do things mentality, but the parent was fighting against that. That's the Pygmalion effect, the idea that people can dramatically be altered by how other people view them and therefore treat them. And that's very true. That's maybe one of the truest, most secret things about human nature there is.
I love that. That's awesome. Cydian, thank you so much for coming on the podcast. This was super insightful.
Thank you. I appreciate you having me on, Robbie.